You have a poll where 359 people out of 525 people uh, have preferred for a certain candidate, and you want to know the confidence interval with 98% confidence level. Now, a lot of people have the misconception that, oh, math is just about formulas. But in order to use the correct formula, you have to know what type of question it is. So words are as important as the formulas. So you have to know that this is a question about confidence interval for P, where P is like the proportion or the percentage of people uh, voting for one candidate. See, normally this happens when you want to know the preference for a candidate that's running for a state senator. They would go out and do this kind of research, right? And then when they have it, they would try to use that sample to figure out what really is the true percentage of people in the entire state that's rooting for that candidate. Okay, so uh, in such a question, you're looking for the proportion of the entire population, and this word estimating population proportion, that is actually the really important word that you should recognize. Okay, see, there are many types of estimating questions, and one is like estimating population proportion, another one would be estimating population mean. There's also another one where you estimate the population variance, and so on and so on. So without knowing correctly what you're going after, you would end up using the wrong formula, and you wouldn't be able to get anywhere. Okay. All right, so once you know that's the proportion question, then you can use the margin of error for the proportion question. So this is the proportion question, a proportion margin of error. And and the next thing is, even if you have the formula, if you don't know what these letters are, you can't use it, so you're not going to get anywhere, right? First, let's talk about z alpha over 2. This alpha over 2 is not multiplied or anything. It's just you have to think of z as a function of alpha over 2. The alpha itself is defined as 1 minus the confidence interval. So since 0.98 or 98% is our confidence level, alpha is the 1 minus confidence level. So you do 1 minus confidence level to give you 0.02. And then the z alpha over 2 is defined as the inverse norm of 1 minus alpha over 2. That's because you have this thing called, actually, this is called alpha level or significance level. And you have this as the percentage. It's like 2%. Okay, so given that you have 2%, what's like the critical value for it? So if you are given a percentage and asking for a critical value, use inverse norm. Sometimes you're given a critical value and you're asked for the percentage, then use the normal CDF. Okay, so here we use the inverse norm, 1 minus alpha over 2. This is another formula that you should memorize. And then you can use the calculator. So I actually got this value from this calculator by doing second vars, and then you do inverse norm, and as you can see, I did 1 minus 0.02 divided by 2, exactly in this form where alpha is 0.02. So if I enter and you get this value 2.3263, right? Okay, so with this value, now what do you do? Well, then you have to know what p hat and q hat are. P hat is what we call the point estimate. I mean, not knowing what's the best value for the entire percentage of the population, because the sample is all you have, the best bet for the entire population is something close to this. So this proportion, 359 divided by 525, that's called the sample proportion, okay, or the point estimate. Okay, sample proportion point estimate value is p hat 359 over 525. Again, using a calculator, I computed this to get 0.6838. In other words, about 68.38% of the entire state is going for this candidate, which means it's pretty good. It's almost a sure thing that he's going to be elected. But again, the question is this big enough of a sample, right? Maybe the sample we took is small, that this is not a good representation of the entire thing. So that's something to think about. Q hat is defined as 1 minus P hat. And if you do that, again, using a calculator, you can get that 0.3162. And then N is just 525 because that's the entire sample size. So we have N, we have P hat, we have Q hat, we have Z alpha over 2. And that's great because now we can just compute this. Just punch these numbers into the calculator. 2.3263, and then times second square root of 0.6838 times 0.3162 and divided by 525, and then that's the value you get. Okay, so that's the value I got. Here's the value. And then once you have the margin of error, see, 68.38% is the best approximation to the population mean. That's the best number, but it comes with some error, and that error is given as 0.0472. We're 98% sure that the error is less or equal to this. Okay, so because this is the how much you're off, the worst case would be this minus this value, and the best case would be this plus that. So you need to compute the plus and minus with the p hat. So that the confidence interval is given by the two numbers p hat plus or minus e. Compute those two numbers, and if you subtract, you get 0.6366. If you add, you get 0.731, and that's the final answer.